All right, get ready because we're going to dive into some pretty hot science today. We've got a whole bunch of articles about NASA's Parker Solar Probe and its big Christmas Eve meetup with the sun.
Yeah, it's going to be quite the meetup. This isn't just a quick hello. The Barker Solar Probe is going to get closer to the sun's surface than any other spacecraft ever has. We're talking just 3.8 million miles away.
3.8 million miles. That still sounds pretty far to me. Can you help me understand just how close that is?
Sure. To put it into perspective, the closest we've ever gotten before was back in 1976 when the Helios 2 spacecraft flew by the sun. The Parker Solar Probe is going to be 7 times closer than that.
Wow, 7 times closer. So, I mean, it's going to be crazy hot out there,
You're
right?
telling me. But that's where the brilliance of this whole mission comes in. This probe is a true engineering marvel. It's built to withstand some of the most intense temperatures you can imagine.
I've read about this heat shield it has. What's so special about it?
It all comes down to the materials. The shield is made from this reinforced carbon composite, and it's got a carbon foam core. That combo lets it handle temperatures up to 2,500 degrees Fahrenheit.
Wait, 2,500 degrees? That's just insane. What about all the sensitive equipment inside?
Well, that's the beauty of the heat shield. It keeps everything inside at a comfy 85 degrees Fahrenheit. It's like a little oasis in the middle of a furnace.
Okay, let's talk speed for a second. This thing is breaking records in that department too, isn't it?
Oh, absolutely. During this flyby, it'll be traveling at a mind-blowing 430,000 miles per hour.
I can't even picture that. How fast is that really? Like, can you give me something to compare it to?
Okay, try to imagine this. At that speed, you could get from Washington, D.C. all the way to Tokyo in under a minute.
That's unbelievable. Okay, so the Parker Solar Probe has been on this mission since 2018. What has it figured out so far?
You know, it's already made some pretty groundbreaking discoveries. One of the most amazing is that it's actually touched the sun.
Hold on, what do you mean touch the sun?
Well, it's crossed what's called the Alphen critical surface, which is like the border between the sun's atmosphere and the solar wind.
Okay, back up for a sec. What exactly is the Alphen critical surface, and what does it mean that the probe has crossed it?
It's a little complicated, but basically the Alphen critical surface is the point where the sun's atmosphere, which is called the corona, turns into this super fast stream of particles we call the solar wind. Getting past that boundary has given us a whole new understanding of how the corona works and how it affects the solar wind.
So that's why it's so important to understand solar wind activity, right? Because it can actually affect us here on Earth.
You got it. The solar wind can mess with satellites, telecommunications, even our power grids. The Parker Solar Probe is helping us crack the code on this whole phenomenon.
And the sun's corona is particularly interesting because it's way hotter than the sun's surface, right?
You're right. It's a bit of a puzzle for solar physicists. We're talking hundreds of times hotter. The Parker Solar Probe is giving us the closest look we've ever had at this region, which will hopefully help us figure out what's causing those super high temperatures.
So how did the probe even manage to get this close to the sun in the first place? It's not like it could just fly straight there.
It took a pretty clever approach, actually. The probe has used the gravity of Venus 7 times, like a slingshot, to get closer and closer to the sun.
Like a cosmic game of billiards? That's pretty amazing. And I read somewhere that it even collected some data about Venus's atmosphere during those flybys.
Oh yeah, definitely. The scientists working on this mission are taking advantage of every opportunity to collect data. It really shows how dedicated and creative they are.
So besides that, what are some of the other cool things the probe has observed so far?
Well, one fascinating thing they found is these strange streamers of material that seem to wrinkle the sun's corona.
Wrinkle the corona, what does that even look like?
Picture that the corona isn't just this smooth, even layer. It's full of dynamic structures, and these streamers of material are flowing through it, creating these rippling patterns.
So we're getting a much more, I don't know, dynamic and intricate picture of the sun than we ever had before.
I got it. And on top of that, the probe has also spotted what they call switchbacks, sudden changes in the direction of the magnetic field in the solar wind.
And those are connected to that whole mystery about why the corona is so hot, right?
Exactly. Scientists think these switchbacks might be playing a big role in moving energy from the sun's core out to the corona, which could explain those crazy high temperatures.
So this Christmas Eve flyby is happening at a really interesting time then.
It sure is. It just happens to be during the sun's solar maximum phase.
And what does that mean exactly?
It means the sun is at its most active. We could expect to see more sunspots, more solar flares, and more of those coronal mass ejections we talked about.
I've heard those can cause some pretty spectacular auroras here on Earth.
You're right, they're beautiful to look at, but they can also cause disruptions to our technology. That's why it's so important for us to understand them.
So we have this amazing probe collecting all this data at crazy speeds, but there's a catch, right? We don't get all the info right away.
That's right, there's a delay in getting all that data back from the probe because of the intense radiation from the sun.
So how long do we have to wait?
We won't get the full download of everything Parker saw during this close encounter until early 2025. But we should get a quick health check-in on December 27th, just a few days after the flyby.
Okay, so we have a little bit of a nail-biting wait, but, I have a feeling it'll be worth it. We're about to get some incredible insights into the heart of our solar system.
I totally agree. And keep in mind, this is just one part of the Parker Solar Probe story. It still has a few more close passes to the sun, scheduled for 2025, before its mission is over.
What will happen to it after that?
Well, eventually it'll run out of fuel and probably get ripped apart by the sun's intense gravity.
That's kind of a sad ending.
It is, but think about it. Aside from its trusty heat shield, which could stay in orbit for thousands of years, the Parker Solar Probe will have given everything it has to advance scientific knowledge. It will become a silent monument to this groundbreaking mission.
It's a testament to human curiosity and our endless quest to understand the cosmos. But before we get too philosophical, we still have a lot more to learn about this mission and what it's uncovered.
Exactly. We've only scratched the surface. Yeah, so much more. The Parker Solar Probe has been uncovering some really amazing things about the sun.
Like what? Give me the scoop.
Okay, so one finding that really surprised even scientists who have been studying the sun for years was the discovery of these magnetic funnels coming out of these giant bubbles on the sun's surface.
Wait, giant bubbles? What are those?
Okay, so picture these massive churning structures on the sun's surface. They're kind of like supersized versions of the bubbles you see in boiling water. The Parker Solar Probe has given us this incredibly close-up view of them, and what's crazy is that it's spotted these magnetic funnels coming out of them.
So what's the deal with these funnels? Why are they important?
Well, scientists think they could be involved in speeding up the solar wind. You see, the solar wind isn't this steady stream of particles. It has these changes in speed and density. And figuring out how those changes happen is one of the big questions the Parker Solar Probe is trying to answer.
That makes sense. So, any other surprises the Parker Solar Probe has thrown at us?
Oh, for sure. Another really interesting thing they found is this dust-free zone around the sun.
A dust-free zone? I thought space was full of dust.
It is, but scientists have always thought that the sun's intense heat would vaporize any dust that got too close. What's really cool is that the Parker Solar Probe actually saw this dust-free zone, proving the theory right.
So how far out does this dust-free zone go?
It reaches out about 3.5 million miles from the sun. It's like the sun has its own little cleaning system going on.
That's an awesome visual. Okay, so as we're getting ready for this Christmas Eve flyby, what are you most excited to learn about?
Well, remember how we were talking about the sun's solar maximum? This flyby is happening right in the middle of all that, which means we have this incredible chance to see the sun at its most active.
So what kind of stuff might we see happening during this active phase?
We might see more of those switchbacks in the solar wind, which could help us solve that coronal heating puzzle. We might also see an increase in coronal mass ejections, which are those huge bursts of plasma and magnetic field that erupt from the sun.
So these observations could help us predict and get ready for space weather here on Earth.
Yeah, absolutely. The more we understand about how the sun acts, the better we can handle any effects it might have on our technology and infrastructure.
All this talk about the sun's activity and how it can affect us really makes you realize how important missions like this are.
It really does. I think we often forget about the sun, but it's such a powerful and dynamic star, and it plays such a big role in our lives. Understanding how it works is so crucial for us here on Earth.
So while everyone's getting excited about this upcoming flyby, we should remember that this is actually one of the last hurrahs for the Parker Solar Probe, right?
Yeah, unfortunately. It's scheduled to make a few more close approaches to the sun in 2025, but after that, its mission is coming to an end.
That's kind of sad to think about. What happens to it when it's done?
Well, like a lot of spacecraft that get too close to the sun, it's probably going to have a pretty dramatic ending. Once it runs out of fuel, it'll eventually get pulled apart by the sun's gravity.
Except for that awesome heat shield, right? What happens to that?
You're right. The heat shield, which has protected the probe through all those close calls with the sun, will probably stay in orbit for thousands, maybe even millions of years.
It's like it'll be a monument to human ingenuity and our drive to explore the universe.
Exactly. A
Yes.
silent reminder, orbiting the sun, of what we can achieve when we put our minds to it. But before we get too poetic about the Parker Solar Probe's fate, let's talk about what its discoveries mean in the bigger sense. What do they tell us about stars and our place in the cosmos?
That's a really good question. And it leads us to one of the most exciting things about this whole mission. The Parker Solar Probe isn't just about understanding our sun, it's giving us insights into stars in general.
That's right. By studying our sun in such detail, we're learning things that apply to stars all over the universe. It's like having a front row seat to the most basic processes happening out there in space.
It really puts things into perspective, doesn't it? This one mission, studying our sun, is giving us a glimpse into how countless stars across the universe work.
It really does. And think about the implications. One of the biggest questions we have about space is whether there's life out there beyond Earth. And to find that out, we need to understand how stars behave, how they interact with their planets, and how those interactions affect the chances for life to exist.
That's a great point. So the data from the Parker Solar Probe could actually be relevant far beyond our own solar system.
Absolutely. And it gets even more exciting when you realize that the Parker Solar Probe isn't the only mission out there studying the sun. There's also the ESA-NASA Solar Orbiter.
Oh yeah, I've heard about that one. How is it different from the Parker Solar Probe?
Well, while the Parker Solar Probe is all about getting super close to the sun and diving into its atmosphere, the Solar Orbiter is taking a wider view. It's observing the sun from a distance, capturing images and data from a broader perspective.
So they're kind of like a team, each one bringing a unique piece of the puzzle to the table.
Exactly. Together, these two missions are giving us this incredible understanding of our star. They're complementing each other's findings, filling in the gaps, and painting a much more complete picture of how the sun behaves.
That's amazing. It's like having two sets of eyes on the sun, each with its own special perspective.
It really shows the power of international collaboration in science, and it's leading to some truly amazing discoveries.
It makes you wonder what other mysteries are out there, just waiting for us to uncover them, right?
Absolutely. And speaking of mysteries, I have one final thought-provoking question for you.
Okay, lay it on me.
So we know that the Parker Solar Probe has already crossed the Alvin critical surface, essentially touching the sun. But as it continues its journey, what other boundaries might it break through? What other long-held beliefs might it challenge?
That is a great question. It really highlights how much we still have to learn about our own star and the universe as a whole.
It's a reminder that science is all about constantly discovering new things. There's always something new to explore, to understand, more questions to ask, and that's what makes it so exciting.
Well said. This has been a really eye-opening deep dive into the world of the Parker Solar Probe.
It really has been fascinating, and who knows what incredible discoveries are still to come.
For all of us here at the Deep Dive, keep looking up and keep asking questions. It really is amazing. It seems like this one mission is revealing so much about how stars work in general.
Yeah, it really is a game changer. And, it makes you think about all the big questions we have, like, are we alone in the universe? To answer that, we need to figure out how stars work, how they interact with planets around them, and if those interactions can support life.
That's so true. So what we're learning from the Parker Solar Probe could be relevant to, well, the entire universe, not just our own little corner of it.
Exactly. And what's even cooler is that the Parker Solar Probe isn't alone in studying the sun. There's also the ESA-NASA Solar Orbiter mission.
Right. I've heard about that one. What's the difference between that and the Parker Solar Probe?
So while the Parker Solar Probe is all about getting up close and personal with the sun, driving right into its atmosphere, the Solar Orbiter is more like taking a step back and looking at the bigger picture. It
Okay.
observes the sun from a distance, giving us a wider view.
So it's like they're both working together, each one providing a different piece of the puzzle.
Exactly. They're like a dynamic duo of solar exploration. Together, they're giving us this incredible understanding of our star. They complement each other's observations, filling in the gaps, and showing us just how complex the sun really is.
Wow, that's so cool. It's like having two different perspectives on the sun.
Yeah, it's a real testament to what we can achieve when different countries work together on science projects, and it's leading to some really groundbreaking stuff.
Makes you wonder what other mysteries are still out there, just waiting to be discovered.
It really does. And it kind of makes me think, what if we've only just scratched the surface? What other boundaries will we break through in the future? What other assumptions will we challenge?
That's a great point. I mean, the Parker Solar Probe has already defied so many expectations by touching the sun. What else might be possible?
Exactly. It just shows you that in science, we're always learning and pushing the boundaries of what we know. There's always something new to explore, something new to understand, and always new questions to ask. And that's what makes it so incredibly exciting.
You've said it perfectly. Well, this has been an absolutely fascinating deep dive into the world of the Parker Solar Probe. Thanks for joining us and sharing your insights.
It's been my pleasure. This mission has truly captured my imagination. I can't wait to see what other amazing discoveries it makes in the future.
And to all our listeners out there, thanks for joining us on this journey of discovery. Remember to keep looking up and never stop questioning the universe around us. This is The Deep Dive, signing off.